Hello everyone, this is going to be part 2 of our review, and I say part 2 but the title here is part 1. Let me change that. This is part 2 of our review. We have done questions 1 to 5 in a previous video, and also done a quick introduction to the AIME and the change in the scoring system. So if you've not seen that already, you can go back there and take a look. For this video, we're going through questions 6 to 10 from the 2025 AIME I. As many of you who have taken AIME before would agree, the first few, it is not too scary. You can do them, you may do it a bit faster or slower, but usually it will be fine. The last few can be pretty difficult. So the middle portion becomes sort of the determining factor in the scores, because getting something from 5 points to 10 points is quite common if you take the AIME, and where you lie in that range has a huge impact on the outcome. Mostly that means trying to solve these questions. And a lot of these problems, it may therefore cause you to just think, I just want to solve them. I will do it any way I can. I don't mind how messy it's going to get. You should be willing to suffer a little bit of bashing, but try to minimize it, because sometimes it will get out of hand faster than you imagine. So let's go over these 5 problems, looking for an efficient approach. Question 6 gives me quite a specific piece of information: an isosceles trapezoid with an inscribed circle tangent to each of its 4 sides. I'll draw a circle first, and then I'll try to draw a trapezium around it that is also isosceles, meaning symmetric. Okay, so this can kind of do. I'm told that the radius is 3 and the area is 72. Let the parallel sides of the trapezoid lengths R and S. Okay, so I should not call the in radius S, or so I should not call the in radius R because of this R and S here. But funnily enough, the R and S, I'm not sure if it's intended as a hint, but it feels like a hint, right? Because it may remind you of your area equals to R times S formula, where R is the in radius and S is the semi-perimeter. Now, just in case you have heard of that before, but you thought it only applies to triangles, well, the only reason why you only heard of it for triangles is that triangles are guaranteed to have an incircle, but other shapes may or may not have an incircle. So if other shapes may or may not have an incircle, this is not a general formula, but whenever there is an incircle, you can chop it up and basically say that these are the heights, which are now the in radius, and if you just get the areas of those 4 smaller triangles and add them up, it would be actually half times the in radius times the sum of the side lengths. So that is R times S. So like I said, I don't want to use R and S because that is going to pose me a bit of overloaded variables. So I'm just going to say that the area is equal to 3 times the perimeter over 2, which means that the perimeter is 48. So that means that I've kind of used the area already. I now also can use the incircle in another way, which is known as Peto's theorem. And Peto's theorem just says that if you have a quadrilateral with an inscribed circle, the opposite sides are going to add up to the same total. And that is quite easy to show. In general, it's just because of equal tangents. So for example, if I draw one where there is no requirement for it to be isosceles trapezium. Then these two parts are equal. These two parts are equal. These two parts are equal. And these two parts are equal. So the two opposite sides clearly all add up to the same thing. Now that means that Peter's theorem gives me R plus S is half of the perimeter, 24. And also that the other two sides are 12. Because the other two sides also sum to 24, but they are equal. So I'm heading somewhere. I am heading somewhere because if R plus S is 24, that is already one thing. But I can form one more equation because I know that this has length 6. So if I use Pythagoras on a triangle here, this would be S minus R over 2 which I can do a bit of computations to get S minus R squared is 432. That is enough. I did not know it would turn out to be so nice when I'm doing all these kinds of information chasing, but my intention is that I want basically to have two pieces of information for R and S, so that either I can solve for R and S or I can get to R squared plus S squared. If I square the other one, then to get R squared plus S squared, I just take the average of these two. So the answer is 504. AIME geometry tends to have a little bit more use of formulas that are this sort of formulas as compared to, let's say, our SMO geometry. In Singapore, we tend to have a lot more of those do some angle chasing, find some cyclic quadrilaterals and similar triangles. I'm not saying that won't happen here, but when it happens in the AIME, you still will often use things like, okay, area equals to RS, Heron's formula, and then things like this, Petot's theorem. A lot more of these kinds of equation forming will happen. So the best way to encounter more of these is through practicing AIME questions, because they do recur on multiple occasions. Next up is number 7. Another counting question where we are pairing up these 12 letters, and then the 6 two-letter words are formed using the pairs in alphabetical order. And then the 6 words themselves are also arranged alphabetically. Now we're asked for the probability that the last word listed contains G. Task number 1, because I don't think I can do this by placing one letter at a time. Task number 1 is just to quickly count the number of ways that this can happen, that they are grouped into 6 pairs of letters. Now be very careful with this. This is surprisingly easy to mess up. If you say that I am going to do 12 choose 2 times 10 choose 2 times 8 choose 2, blah, 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 this is already wrong. The reason is that if you do this, you have basically decided on a first pair, a second pair, a third pair, and so on. But when I said randomly grouped, I am not yet concerned with the order of the letters or the order of the pairs of letters. Now that can be remedied by dividing by 6 factorial, but a much simpler way to do this would just be to say, look at letter A, decide what it gets paired with. There are 11 choices. After it has been paired with something, just take them out from the pool and look for the next available letter. It has 9 choices and so on. So this would be the number of ways. I am not going to calculate this yet because I suspect things will cancel at the end. So this is the number of ways to group them without restriction. Now, the next thing is I am trying to find the number of them where the last word contains G. And I feel like a good way to depict it would be as 6 dominoes, where each domino contains a letter. Effectively, what happens is that I am told that this is the ordering, is alphabetical, and I'm also told that this is going to be true. In here, what I'm basically doing with the less than sign is just alphabetical order. But you can treat it as they are just the numbers 1 to 12 as well, where you're putting them into these boxes or these dominoes. And I want to put 7 in the bottom row. The interesting thing that I observe is there is a long chain. So the long chain means that I can't actually put something so small in the last word or in the last pair. It is going to be already at least 6 or F. So for example, if I were to put G or 7 here, you are forced to have this all the way up. And this would give me any arrangement of those 5 or 5 factorial ways. So slightly more interesting would be if I put the 7 or the G on the left. If I put it on the left, it means that the last word here, there is one thing to do. These 5 here, there is also something to do. So let's see if we can decide which one to do first. Now, if for example I do 1, 2, 3, 4, 5 here, I know 6 can appear anywhere here, and then all the others from 8 to 12 can go anywhere. But if let's say I did 1, 2, 3, 4, 6 here, then the 5 can go to anywhere here. If I did 5 here, 4 can go anywhere here. So it does change. I can't actually add up all of those cases because there are supposed to be 5 numbers from 1 to 6. So I could just split it into 6 cases and add them up. But I think that it just means 2 of them are paired up together. So from 1 to 6, I will pair 2 of them. And then once I've paired the 2 of them, the smaller one is going to be in the left column. I can just sort all 5 of them. The sorting is fixed. So it would just be 6 choose 2 ways to decide which 2 go together. Once you've decided which 2 go together, for example, if I decide 3 and 5 go together, then it's 1, 2, 3, 5, 4, and 6, which have to be arranged in the exact order. Everything else can just be arranged in 5 factorial ways. So this is, I think, the most efficient way to do the counting. you end up with 1920, and then we simplify you end up with 128 over 693 as your probability, and your answer is 821. Question 8 is a complex number question. So this is another thing why it is AIME is a useful practice for our SMO Open round 1, because it does have some of these kinds of questions which it's hard to find Olympiad questions on complex numbers, Olympiad questions on vectors, Olympiad questions on 3D geometry. We have A-level questions, and then after that you have got just Olympiad questions which are quite far apart in difficulty sometimes. Right? So this is a good practice source, and also it tends to not require a huge amount of knowledge beyond, let's say, an A level. It's just that it is an interesting application. First things first, this is the equation of a circle. The distance from 7 to 25 plus 20i is 5. In complex numbers, and even in real numbers, think of absolute value of a difference as being the distance between these two when they are drawn out. So for real numbers on the number line, or complex numbers, it will be on the complex plane or your Argand diagram. So likewise, this is the distance between z and 4 plus k, and the distance between z and 3i plus k. 4 plus k and 3i plus k will be both just points, and so this is basically a perpendicular bisector of those 2 points. So with that, I realized that it's just saying that this is a circle, this is a line, it has one complex solution, means one intersection, which means that they are tangent. That is the end of my applications of complex numbers. The rest of this, I will treat it as coordinate geometry. So z 25 plus 20i, distance is 5, means that 25, 20, you have a circle of radius 5, and then somewhere else I have got 4 plus k 0, and I have got 3i plus k, that's k3. The perpendicular bisector is supposed to be tangent. This is actually a little bit better than I expected my initial drawing to be, because I don't know k, but that is good. So this is the figure that I am thinking of. You can imagine why this is unique. You can solve for k, because if I slide this line and move it across, it is going to be the case that the intersections would either become more than 1, or that there will be no intersections. With the exception that maybe there's also one down here if I slide it far enough, then this would also work. Now, the interesting thing here is that you can actually say that from here, I can do some geometry to get the sum of values of k. Because in a way, the midline here between these two will go through like the average of these two possible values. But I think that's not necessary to do, to be honest. If you want to explore how that works, it'll be quite nice. But equation-wise, I'm happy to just use a discriminant on a quadratic. So let's just go with that. So this is the equation. The k3 and 4 plus k0, the gradient is actually negative 3 over 4, which means that this gradient is going to be 4 over 3. So the gradient is 4 over 3 of these lines. Then actually it goes back to the gradient of this is minus 3 over 4. Okay, so I think maybe I actually do not need to do full-fledged coordinate geometry, do I? If I already know that the gradient of this is minus 3 over 4, it would be literally just 3 and minus 4, because it's a 3, 4, 5 triangle. This will be minus 4 over 3. So 29, 4 is the change in x, minus 3 is the change in y. Okay, so this would be the pair of points where it would be tangent. The midpoint of this is k plus 2 and 3 over 2. And so I can just, for both of these, solve for the value of k. That gives me a gradient of 4 over 3. This is on one side, and then the other side, instead of 29, 17, you have got 21, 23. So I think this is straightforward enough. To save a bit of time, I will just say that the solutions you get are k is 23 over 8 and 123 over 8. So answer is 077. Didn't actually even need the equation of the circle, did I? If you had written the equation of the circle and the equation of the line in the terms of k, and then got the intersections, find out what value would make it such that the discriminant is 0, that was my initial thought. But as I looked at the diagram, I think this is the compromise between solving it purely geometrically with too much like visualization needed, and solving it purely algebraically, which may take a bit longer. So this is somewhere in between, but you can go in both directions as well. Okay. Question 9. A parabola with equation y equals to x squared minus 4. This is not to scale at all. Maybe I should at least try to have the intercepts look a bit more correct, because I'm asked to find a unique point where stuff intersect, so perhaps that may be better to do. Okay, so this is a parabola before rotation, and then I need to rotate it 60 degrees counterclockwise about the origin. So that means that I'm going to have I don't actually know how to draw this, to be honest, very well. Maybe I'm not going to draw it then. So the unique point in the fourth quadrant where the original parabola and its image intersect. So that means there's some point here. And then after that, when you rotate it, it means that something from here rotated 60 degrees over to here. And then that's why it got intersected at that one point. Actually, that just means that because this parabola is symmetric, and this is an equilateral triangle, am I not just looking for like an equilateral triangle, something like this, where I know that this is a horizontal line? It's going to be symmetric for sure. And if the angle like this is too big, the angle down here is too small, but somewhere in between, I'll get exactly 60 degrees. And I'm told it's unique. So when they tell me it's unique, in a sense, it is permission for me to guess one place where it can work. So this will definitely work. And I just need to find an equilateral triangle. So let's call this thing here just a squared minus 4. This is negative a squared minus 4. And the distance here would be 2a. That looks like it will be quadratic, so that should be fine. This is okay with me because I am already told that I expect some square roots to show up. I can't factorize this, but that is okay. This is a squared. I don't need to square root this again because they are asking me about the y coordinate, which is a squared minus 4. And I expected it to be that a squared minus 4 is negative, so it should be 11 minus square root 57, and that matches with the skeleton that I'm expecting. So it would be 3 minus square root 57 over 2. And this is 62. Let's keep formatting consistent, shall we? As you can tell, the questions are not really also going to be objectively getting harder, let's say in a region from like 1 to 5 or 6 to 10. So many of these problems here, it's just different kinds of observations. I emphasize again, please feel very free to skip around because with 3 hours of time, you can get many looks at the same question. Like 1 hour later, suddenly this seems very obvious to you that it must be like this. Or like 1 hour later, maybe you started to try to draw it, and then 1 hour later you realize that I don't need to draw it, I can just look for a point that will rotate to the new point. So these kinds of observations can come a little bit later. Okay. Right, now that leaves us with number 10. Another fairly long-winded question, basically telling you that you want to have 1/3 of a Sudoku. And I want to count the number of ways to fill up, let's say 1/3, meaning 3 rows of a Sudoku, such that it still satisfies the Sudoku rules. we are not really asked to satisfy the Sudoku rules in a way that we can solve the whole Sudoku. So in other words, technically, I'm not sure whether this will cause me problems below, but I just need to count it for this top part. Now, I can say safely, without loss of generality, that the first row can be anything I want, because if I swap any two numbers, like all the ones and all the twos, I swap them, that will still be valid. Right? You just need to have each of the rows and the boxes containing 1 to 9. So I can assume that there are 9 factorial ways to start with, but that it just began with 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's one row. Now, for each of these, I also realized that I can easily swap, let's say, among any block of 3. I can just swap them among themselves, and because there's no rest of the Sudoku, it doesn't affect the row or the block. So technically speaking, I just need to think about which 3 numbers will come into here, and then there'll always be an extra times 3 factorial somewhere. Okay, so I can look at this next one here, and surprisingly, there are not that many like meaningfully different cases to consider. Okay, now the first case, and I'm talking about now filling these as 3-digit sets where we can then rearrange it. So there's another 3 factorial to the power of 6 already. I'm now just filling up sets without order. If I just repeated one of these, let's say 4, 5, 6. Now the 4, 5, 6 can no longer appear anywhere except entirely here. The 7, 8, 9 would then all have to appear here and here. The 1, 2, 3 would all have to appear here and here. So in other words, if this thing was just following 4, 5, 6, one way, everything is fixed. Likewise, if that was 7, 8, 9, the exact same thing happens. So there are these two scenarios where it's just one way. It may not seem like those two scenarios are a very good thing to consider, but realize that these are just 3 numbers out of 4, 5, 6, 7, 8, 9. There are 6 choose 3 ways, which is 20 choices, 2 of which are an exact copy of this or this, and the other remaining 18 ways are just going to be 2 from one and 1 from the other. And all of those are basically the same because of symmetry, they can be considered as the same case. So I can just try writing this as 4, 5, 7, basically 2 from one of them and 1 from the other, and see what is now going to be locked. The bottom row left is locked. That would be 6, 8, and 9. Now, the 4 and 5 must both come here because they are locked out from there. The 7 must come here. The 8 must come here. The 9 must also come here. And I think I forgot 6 also, right? 6 is here. So I basically am just left with the numbers 1, 2, and 3. The numbers 1, 2, and 3, there are 2 blanks here, and 2 of the numbers will appear in this diagonal. There is a pair of blanks here, and 1 of the numbers will appear in the other diagonal. So that will give me 3 ways to choose which one appears in which diagonal. And this is everything. So 9 factorial times 3 factorial to the power of 6 times 2 plus 18 times 3, which is 56. I'm pretty confident that I have not messed up because of the fact that I can see the only prime factors of this will be 2, 3, 5, and 7. Right? So that's a good sign. The only prime factors are 2, 3, 5, and 7. Let's just fast forward the factorization of each of these, but do it very carefully. You will end up with this many 2s, 3s, 1 5, only 1 from 9 factorial, and 2 7s from 9 factorial and the 56. Don't forget that it's 5 times 1 when doing the answer extraction at the end, which should give you 81. Alright, so that is our middle section of questions 6 through 10. They are definitely not so easy, but as you can see, I've made all the efforts to reduce the amount of steps that are required. I've also not written down everything explicitly, so if I were to really write this out, this would take a page to describe. But intuitively, as a contestant, you don't really need a whole page of workings because you know what you are thinking, and when you can communicate it to yourself, that is good enough. I hope that was clear. If you have any questions, as usual, let me know in the comments below. And for the final set of 5 questions, I will be going over that in a few days' time. So that's all for this video. Thank you for watching and see you again soon.